About CTC here and what we do. I want to point you out to the stay in touch options at the bottom there. Visit CAD Technology Center. Visit our events page. See what else we have going on. Check out our YouTube channel. That's where we will be posting these videos. And also get in touch with us on Twitter, CTCBIM. Sid will be your presenter today. He's our applications engineer, specifically in the MEP experts. So with that, I will send it over to him.
Good afternoon, everyone. My name is Sid, and I'll be doing the presentation on best practices for exporting to gbXML. So this is just a brief overview of the topics we'll be touching upon during this presentation. We'll go over what gbXML exactly is, just an introduction to this file format if you haven't heard of it or used it before. We'll look at settings then for exporting to gbXML in Revit, and we'll go over all the picks and clicks that you need to make and what they would exactly imply. We would look at how you would account for volumes of cavities, shafts, and chases, and how they get interpreted in Revit, and how it handles those situations. We'll also look at errors and warnings, some of them that you will see related to spaces and rooms as you try to export them out. And we'll finally look at the gbXML schema itself and how that file format exactly looks and what some of the things in those files mean. Introduction of gbXML was developed in 1999 by Green Building Studio. Green Building XML is basically an XML file format that would contain building information relevant to energy usage. It's funded by the US Department of Energy, and it's intended for easier transfer of data between designing tools and your energy modeling tools. So you have your design in Revit, and you've got your energy modeling done in TrainTrace or IES or Ecotect or some other energy modeling program. And being able to transfer information to and from these softwares would take out the manual process of having to input them. Release of version 5.10 for gbXML, and you also have a gbXML schema validator, which we'll also look at towards the end. It basically would allow you to validate your gbXML models based on certain standard tests that the gbXML developers came up with. What we'll do now is jump into my application here in Revit. And I have this small sample building that I made just for this exercise. And as you can see here, it's got some walls here placed. It's got floor and ceiling elements. It's got some doors as well. And there are some really narrow spaces in here. And we'll see how Revit would go about handling these spaces when you try to create and export a gbXML file out of it. Give you a better perspective of what we have here. We can look at this in 3D, and this is basically what you have here. Now, to export a gbXML, the first place that you would go to is your application menu, and you'll click on the export options and look for gbXML. If you're in there, you may see a message like this show up. So it basically tells you that you have chosen to compute only areas in the computation settings, which means Revit approximates the volumes for spaces. Do you want to enable the areas and volumes settings instead? So at this point, what you can do is you can hit yes, and you can save these settings and it'll exit out of the export process. And now if I go back to that floor plan, and let's suppose that I try to place a space, so I'll go to the Analyze tab and look for space. And now when I bring in a space, notice that particular space, area and volume computation. So what that dialog box essentially did was, in my project, if I go to the Architecture tab and look at the room and area dropdown, I have the area and volume computations. So what Revit did is it automatically went in there and turned on the areas and volume computations since I had the areas only checked by default. So if I have it set to this and I go back to try and export a gbXML, it'll show that message again. So if I hit no here, it'll leave that as areas and it'll not do any volume computations as you see here. So we'll now go ahead and look at some of the other settings that are in there as you try to export a gbXML. So to know, the first parameter that you see here is your office space. So you can set your building type, and these are building types that Revit has based on ASHRAE, CIBSE, and some other standards. So you'll see all of those listed here, and you can choose the building service type. It also shows the space here that is created inside your project, and you can of course orbit around it in a regular 3D view. You can also change the view from a shaded to a wireframe, and it then shows up this way. You can set the location for your project. So by default, it goes to this particular location, but then I can click on this button here and it'll list locations closest to the location that I'm at. And it'll also show me a map, an interactive map that I can use to go to a certain location. So if, for example, I type in our office address here and search for that address, it is going to go ahead and search for that address and locate weather stations that are closest to this particular address. So I can choose a weather station from this list or go with the closest weather station that I have to this location. Use daylight savings time, and what it will do is it will just go increment the calculations by an hour to account for the daylight savings time. If you go to the weather tab, you see the dry bulb, wet bulb, and the daily range temperatures for every month station. Now, if your weather station or if your location is going to have a slightly different weather from what that weather station shows you, you can uncheck this box here and manually put in a value for that for the weather for that particular month of the year. Heating design temperature, and you can also set a clearness number, which will basically indicate if a typical day that you're going to do the calculations for is going to be cloudy or sunny. I'll check this box again and I'll leave this location and I'll hit OK here. The next property that you can assign is for the ground plane, and the ground plane is basically the level from which your building is going to be constructed. Anything below the ground plane would be treated as underground for your gbXML export. So that is one thing to keep in mind. The export category now, this is a recent addition that they've added to your gbXML export settings, and you can either export spaces or you can export rooms. And depending on what item you choose here, the options that follow would then change accordingly. So you can see that if I set it to rooms, the options that I see here are going to decrease to a certain extent. So with rooms selected, I can choose the export complexity. Now there are no rooms placed in my model, so we do not see a preview in here for the rooms. As soon as I set it to space, it shows me a preview for that space. Switch it back to rooms. And the next set of parameters that we have are going to control the kind of export that you will have going out of Revit. Simple will basically mean that it's going to push out your gbXML model, and for curtain walls and curtain panels, it's going to send them out as one single panel. If I set it up as simple with shading surfaces, it's also going to push out the shading surfaces if I have any in my model. What complex is going to do is it's going to push the curtain walls as a single panel instead of a combined panel. Okay, and then I can have complex with shading surfaces. You can also have complex with mullions and shading surfaces. So they will also be treated as shading surfaces instead. Thermal properties. So you can choose to include thermal properties for the different item room, and it will do that as you export it. Now, how this information would translate into a particular software is something you'll have to play around with and see if having this checkbox checked would make any impact on that. The project phase and toggle between existing and new construction. And you can also set the sliver space tolerance. So we'll come back to this sliver space tolerance property in a few minutes here. So I'll set the export category from rooms back to spaces and look at some of those additional properties that we get when I try to export a space. So when you try to export a space, you can also choose your building service. So you have the standard building service types that you can choose from. Right, you can choose a building construction, and this was a new feature that I believe got added to 2013, where you can click on this button here, and you can either use the default constructions for these different category of elements that are in your project, or you can override them with a manual property instead. So instead of using the roof that is present in the project, with this material instead with that particular U value. Similarly, I could do that for the exterior walls, ceilings, floors, and so on. Okay. Building infiltration class can also be set if you are trying to export spaces. And the building infiltration class, you can choose between tight, medium, and loose. So a loose building infiltration class would set your infiltration at about 0.076 CFM per square foot. Medium would give out about 0.038 CFM per square foot. And for a tight infiltration class, you will have about 0.019 CFM per square foot. To export default values or uncheck this. And what this will do is it will export the default values for your occupancy, lighting load, power load, your occupancy, lighting, and power schedules as well. So it is going to go with the defaults if you have that box checked. The next set of parameters will be found on the Details tab. So on the Details tab, you can choose between spaces and analytical surfaces. So before we look at these options, let's actually go ahead and save settings and just drop spaces throughout the model. So I'll go to the Analyze tab, I'll click on space, and this time what I'll do is set to place spaces automatically. And it will tell me that it has created 10 spaces automatically. Now notice that is placed in these narrow areas here. I'll turn on my thin lines just so that it gives you a more better clarity. So you'll notice that it doesn't place a space here in these narrow areas, and it also hasn't placed a space in this narrow area that I have here. Now those could be areas where you could have a chase for your plumbing lines to go down or for your ductwork to go down, and you may not necessarily want that as a conditioned space. Now I can go to the visibility graphics and expand my spaces and turn on the interior and the reference checkboxes. And when I do that, it gives me a better look at where the spaces have been created and how they exactly appear in my model. Right, so once we have these spaces placed, I can then go back to my application menu and go to export again and select gbXML. So I'll still leave this to no, and you will see your spaces show up this way in your model. Now I can go to the Details tab and I can choose if I want to export spaces or if I want to export analytical surfaces. If I set it to analytical surfaces, you'll notice right away that the display of your model changes here in this preview. You can expand this, and this is basically your default zone that you see. And you'll notice right away that my spaces have these warnings. So regardless of whether I'm set to spaces or analytical surfaces, there are warnings associated with my spaces. So one common warning that you'll come across when you export a gbXML or even do a heating and cooling load analysis inside Revit itself is with regard to spaces not being upper bounded by a roof, ceiling, or floor element. So if you see a message like this, you can resolve this. And what that message is basically referring to is that if I select the space, you'll notice that there are these properties that constrain that space. So spaces work by looking for room bounding elements in your model. As soon as spaces find room bounding elements, they would terminate the space at that point. So for example, if I select this basic generic wall that I have here, this wall has a room bounding property that is checked. So that is what tells the space that it needs to be constrained by that wall. Floor, the other walls, and the roof elements would all have that constraint to them. But this space does not have a constraint on the upper end. And the reason it's doing that is because the limit offset for that space is set at 8 feet. With the limit offset set at 8 feet, it's going to terminate the space at that elevation, regardless of whether it has a roof or not at that elevation. So for example, if I go into the section view, I can select the space here, and you'll notice right away that this space is not upper bounded by a roof, ceiling, or another floor element, and that is what that message is essentially referring to. So what you can do at that point is you can grab these grips and move it across this way, and it should automatically fill up the volume of that room. Now, the reason it is going even beyond that point is because I just have area computations turned on. As you can see, it's not doing any volume computations. So when it is set to that setting, notice that even if I have the roof element selected, which is supposed to be a room bounding element, my space would still extend beyond the roof element. So if I want to constrain it that way, I'll have to make sure that I am on the architecture tab, and on the rooms and areas, I can go to my area and volume computations and turn on the areas and volumes. And if I hit OK at this point, now you'll notice that even though my space is set to exceed the boundary for that room, it is terminating the space at the roof. And the reason it's doing that is because this roof is set to a room bounding element. Okay, so that is one way to control the volume of your spaces, and you'll also see the volume that it's calculating for that space. So you can either do that manually for each and every space that you placed in your model, or alternately, what you could do is make sure that these values are set correctly right at the beginning before you place your space. So when you go to analyze and doesn't let you place a space in a section view. So if I go back to this floor plan and I select space, right up here on the options bar, you have the option to set the upper limit and the offset from the level that you're on. So as long as you have these values set correctly, your space should fill up the volume correctly for your room. Okay, so now if I go back into that section, another look at these constraints here. So the level is going to be a parameter that is grayed out, and it's going to basically reference the view from which you create your space. The upper limit is going to obviously be the upper limit for that space. The limit offset parameter is going to refer to the offset from the upper limit that you set your space at. And the base offset parameter is going to be the offset from the base or the level that you set your space at. So for example, if I set the base offset parameter to a negative 2 feet, it tries to take my space negative 2 feet below level 1, but it's not able to do that since I have my floor set as a room bounding element. Control or contain the size of or volume of your spaces is by setting your upper limit to level 2 and your limit offset and your base offset to 0 in this case. So when I do that, if I have or a model that has ceilings that are at different elevations, even if I set the upper limit to level 2 for those spaces, it will terminate at the ceiling as long as those ceilings are created as room bounding elements. So we need to do this for all our spaces. So if I go back to export and I look at gbXML, And now if I go to the details tab and expand that default zone, I'll notice that space 3 does not have that warning anymore on it. So this process would have to be repeated for all the other spaces that we have inside our So if I go back to that floor plan, I can one space at a time by selecting it, or alternately what you could do is just a window selection around your entire model, and then you could click on filter up on your ribbon and just filter out the spaces here. Filtered out, I can then make sure that the upper limit for all of these spaces is set to level 2 and the limit offset is set to 0. So this way I can make sure that all my spaces are going to be correctly bound and the volume that it references is correct. So now if I go to export and go to gbXML, notice that those warnings would disappear for all of my spaces. Now let's take another look at this sliver space tolerance warning that we get, or the sliver space tolerance setting that you have. Now the sliver space tolerance is set at 1 feet. I'll just save settings and I'll just do a dimension for the distance between these walls that I have. So if I go to annotate, for example, and do a dimension here, dimension between these wall items is set at 1 feet. So my sliver space tolerance also value of 1 feet at this point. So if I go to the details tab and select analytical surfaces, you'll notice that if the sliver space tolerance is set at 1 feet, what Revit is doing is it's ignoring the thickness or the gap between those walls, and it is approximating that volume by the adjoining volumes that I have. For example, if I go to the general tab again and set my sliver space tolerance to say 8 inches, what Revit is going to do is it's no longer going to assume that that is a sliver space. So it is going to ignore that, and I'll see that right away. Okay, further, if I go to the details tab and expand the default zone and expand the space here, I need to find out what space I'm looking at in this area. So what I can do is I can just go about highlighting my spaces till I find that, or alternately I could go to my floor plan and find out what that space name is. So in this case, it's this space 9 that I'm looking at. It lists all the exterior, interior walls and the air gap as well. Okay, now I have 3 exterior walls here and I can select between them. And it's reading this wall now as an exterior wall, which would be incorrect if I send it out as a gbXML file at this point. As soon as I go to the general tab and set the sliver space tolerance to 1 feet again, and now if I go to the details tab and go to space 9 and look at exterior walls, it automatically gets rid of that, and now it knows that that is an interior wall. Right, so it is very important that you set your sliver space tolerance correctly so that you account for the right spaces in your model and allow Revit to approximate the other spaces in your model before you export a gbXML. Also, the names here for your exterior walls, floors, and air gaps and so on are going to refer to a certain code. So these codes can be found by going into your Revit wiki help. I have found this to be very useful. So for example, if I look at this here, it gives me a description of what that code refers to. So the first letter in there refers to the orientation, and this is telling me that it's a south orientation wall. The number 9 refers to the primary space that it's going to belong to. So since this is part of space 9, I see that in here. Space 13 is going to refer to the other space that it's sharing that wall with, right? And you can look at these different parameters here and then understand how those surfaces are being read, and it'll have that information also contained in that XML file that we will export in some time. Okay, so you can look at your analytical surfaces this way. Set it back to spaces. There are other settings that you can also look at, and these settings, again, you'd have to play around and see if it would be best to define these settings in here, or it's better if you define these settings in whatever program you intend to run that gbXML file in. It could be Train Trace or IES or Ecotect or Green Building Studio. Property that you see is for your space, and it's the space type. So if you click on this button with the three dots on it, it opens up the different types of spaces you can choose from. And depending on how that space is going to be conditioned, these energy analysis parameters would then change accordingly. So for example, if I go to a bank customer area, the area per person for the default building would change from 307.54 square foot to 35.88 square foot. So all of these parameters would then change based on the kind of space you select in here. There are also occupancy, lighting, and power schedules that you can customize before you push them out to your gbXML. So if I click on that button with, you can look at your schedule here, and there are options to create a new schedule from scratch, or you could duplicate a schedule that comes closest to the schedule you intend to finally use. And you can also rename an existing schedule to something more that you will understand. Now, in this schedule, it gives you a graphical representation of how the occupancy is going to change over a 24-hour period. So if you make any edits to these values here for the factor, so if I set the 6 a.m. also at 10%, for example, you'll see that getting reflected on the graph instantly. So you can set this up for your occupancy schedule. You can do that for the lighting and power schedules as well. Construction type can be set up just for that particular space. So if I want to have a construction that would be used for around, say, 70% of my building, I can assign that construction material to that. And then for those remaining 30% of my spaces, if I want them to be overridden, I can then create a new construction template. I can duplicate this if I need to do that as well. And you can choose the materials that you want to have override the existing materials for that space. So you can select those materials here, and it'll override those materials when you export your gbXML. The people and electrical loads values are coming from the space type that we have. So for example, the bank customer area that we've assigned for the space has a for the sensible and latent heat gain per person. And now if I go to the people, I see the heat gain per person, and it's reading those same exact values that I have for that space. Now, if I need to override it, I can obviously go to specified here and override the values instead. Similarly, the occupancy is also coming from the space type that I've set up. And if I go from default to specified, you can either choose the number of people for that space or specify a square footage per person. Similarly, the electrical loads are also coming from the space type setting. So the power load that you see here and the load density, as well as the lighting load and the lighting density, is coming from the space type setting that you have. Specified, you can then choose the contribution to the plenum, and it'll account for that as well. And you can also go to actual, and what it'll do at that point is use the actual light fixtures that you may have in your model. Actual, it goes to 0, which is correct in this case since I don't have any light fixtures placed in that space. So there are properties that are specific to your spaces, which you will see here, and there are properties that are specific to your zones. So if I select that zone, which is the default for all the spaces that I have, I can then choose a service type for that entire zone. You can choose the heating information for that zone, which would include a heating set point, a heating air temperature. You can set the humidification control as well if you intend to have that in your model. cooling information, and you'll find similar properties for the cooling as well. And you can also type in outdoor air information, and it gives you three options for the outdoor air. You can put in an outdoor air per person, an outdoor air per area, or an air changes per hour. And what Revit will do is it will consider the one that is most critical for your design if you do the heating and cooling analysis internally. If you export this information out, it will also take that information as you push out that gbXML file. So you can have multiple categories selected here and put values for that. Okay, so those are some of the settings on the details tab that you can configure before you export your gbXML. And we looked at some of the options we had on the general tab as well. So I can save these settings. And actually, let's just go ahead and export that gbXML file. So now if I go to export and select gbXML, I need to make sure that my sliver space tolerance is set up correctly, and I can look at my analytical surfaces and make sure that there are no gaps in my model so that it pushes out the information correctly. So I can hit next at this point, and I can save my gbXML file location, and it will save that as an XML file. And once that file is saved, what we can do is look at that file itself and see the kind of properties that we have on it. So if I double click and open up this XML file, it's got these different properties that you see here, and it's got information, for example, for the volume and unit areas that it's going to use. You have building type, you have the latitude, longitude information, the name for the location, and it's got these items here like planar geometry. It's got a poly loop which gives you the coordinates. So these are all coordinates for each of the surfaces that we looked at previously. So this is the kind of information that is contained in your XML file, and what you can do at this point is go back to that slideshow. Let's look at those properties in a little more in detail. So gbXML files basically use three parent nodes. You've got a shell geometry node that defines the inner surfaces of your spaces. You've got space boundary nodes that define the center line of your surface, and you've got surface nodes that define surfaces not contained in the space boundary, which would be like your shading devices. And it would also account for openings on your spaces. So all of that information that you saw in that XML file is categorized basically into these three categories. Geometry assumes that the x positive direction is in east, the y positive direction is north, and the z positive direction is facing towards the sky. The orientation of a surface is given by the normal vector using a right-hand rule, and both values of the coordinates and the order are important. So if you look at just this sample here, for example, you can see that the way these coordinates are defined, the way it goes from one point to another is going to then determine the normal vector, and that is what will be used when you export it out to give a direction to that surface. And you can see that there are these poly loops here, and each poly loop will basically define a surface. So whatever is contained within these poly loops is going to define one surface. Okay, they can start with any coordinate in a set, but the order in which they go from that coordinate is what is going to determine the normal vector direction. Coordinate here is going to be my x coordinate, the second coordinate would be the y, and the third coordinate is the z coordinate. So that is the typical kind of text inside the XML that you will find for the shell geometry. For the shell geometry, you will also find an ID that will refer to the space name and the unit that it's on. And you can have multiple poly loops. Okay, so the ID value must be unique for a shell geometry. And you can have unlimited poly loop elements, since there can be unlimited surfaces that form your shell geometry. So there are two shown in this example. And each coordinate should basically be repeated at least on another surface in order for you to get a completely enclosed volume. Okay, let's look at some of the properties that you will come across if you look at a space boundary. So on the space boundary, the surface ID reference will be the same for interior surfaces. So if you've got interior surfaces, this particular ID that you look at will be the same. And you will have a unique ID if it is going to define an exterior surface. Another thing to note about your space boundary is that you'll have one poly loop per space boundary instead of multiple poly loops that you have for the shell geometry. Okay, shell geometries would define the inner surfaces of wall, floor, and ceiling, and your space boundaries would typically define the location of the center line of a surface. And the way these two are related is used by gbXML to obtain the thickness if that is being used by your gbXML authoring software. So it will compare the coordinate of the shell geometry element with the corresponding space boundary element. And if there is a difference between that, it will assume that that is going to account for the thickness of that surface. So before we get on to the question and answer round, there are a few other pointers I wanted to mention. Now you can simplify the export process and make it easier for Revit to export gbXML files if you've got spaces that are going in a similar way. So ideally what you can do is you can have a separate sort of energy model that you will use to push out of Revit. And the reason you may want to do that is, for example, if I have these two spaces being conditioned in a similar way, what I can do is I can delete this space. Now, when I delete a space, Revit is going to show up a warning telling me that it's deleted from all model views, but still remains in the project. So the space can be removed from any schedule or placed back in the model using the space command. So it's still existing, although I don't see it. And the way I know it's existing is because if I go to the application menu, go to export and select gbXML in here. And now if I go to the details tab, 9 space in here. And this is the warning you would typically see for a space that got deleted. So it will say that the space is not placed. Physical properties such as areas will display as not placed in schedules. And you can place the space using the option bar in the space tool, or you can delete it in a schedule. And it will be ignored in the energy analysis model. So if I save the settings here and create a schedule for my spaces. So if I go to the view tab, go to schedules and select a schedule. And let's say I create that. And let's suppose I just add the space name and number and volume, for example. And if I hit OK, you will see that space 9 still exists, but the volume reads as not placed. So if I want to delete this space, what I can do is I can select it and I can delete this row. So it will tell me at this point that it's going to delete it from the project. So that would be the way you would get rid of spaces if you don't need them in your model. So once that space is deleted, you can then select this wall and set it to be non-room bounding. And when you do that, the volume of this space will automatically update to fill up that room as well. So if you're going to have rooms that are going to be conditioned in a similar way, then I would recommend having a separate energy model with the appropriate room bounding elements, so that the spaces are more easy to manage that way. And your gbXML file is a lot simpler, and chances of getting a valid gbXML file would increase that way. Okay, so if I undo that, another thing to keep in mind is that the sliver space tolerance would account for this kind of a space and approximate it with the spaces around if it has a space on all its sides. So in this example, if I were to try and export a gbXML and I don't have a space at that point, my sliver space tolerance is set this way. Now if I go to the details tab and look at my analytical model, it hasn't accounted for that gap in between. And the reason it's doing that is because it does not have a space on the other side of that narrow element there to approximate it with the surrounding volumes. So that is another thing to keep in mind, that when you set the sliver space tolerance, make sure that that area that you're targeting has a space on either side so that Revit is able to approximate it with the adjoining sides. Okay, so with that, we come to the end of our presentation. So any questions, comments?
Presentation mode is now disabled.
So any questions, comments? So we have a question here. And it's basically that train requires outside air per space instead of by zone. How should we handle that? So what you could do is at that point you could make sure that your zones kind of overlap your spaces so that you can assign a property to that zone and the space at the same time. And maybe that could be an alternative workaround for what you're trying to do. Any other questions, suggestions? Aren't any other questions? We would always like to hear back from you. We appreciate feedback from you on what you would like us to show you, and we'd be more than happy to present that as part of a webinar or any other format that you would like to have us show that to you. So do keep in touch and let us know how we did on this webinar, because we would really like to improve on this, and hope to talk to you soon. Have a nice day.